Hi guys, so in the previous video we learned how in liver fructose is converted into dihydroxyacetone phosphate and glyceraldehyde, which are intermediates of glycolysis, and this remaining part of the reaction would include how glyceraldehyde would first convert it into dihydroxyacetone phosphate and dihydroxyacetone phosphate to glyceraldehyde 3-phosphate, and this includes 4 more reactions and it's not that hard either. So starting with glyceraldehyde, the first reaction is catalyzed by alcohol dehydrogenase, and whenever you see any reaction catalyzed by dehydrogenase enzyme, then the reactant is either oxidized or reduced. So in this case, this molecule gets reduced to make glycerol. And usually in dehydrogenase enzyme we have involvement of NADH and NAD+, and you can just predict whether NADH is going to make NAD+ or NAD+ is going to make NADH. Now let's say in this case this is reduced. So if this glyceraldehyde is reduced, then this has to be oxidized. So that's how we get NAD+. The reaction number 5. In reaction number 5, we convert glycerol to glycerol 3-phosphate. And again, to predict the enzyme, I told you guys before that whenever there's a kinase enzyme, it involves either attachment of phosphate to a molecule, or phosphate from the molecule goes and attaches with ADP to make ATP. In this case, it's the first case, and ATP is converted into ADP, and this phosphate goes and attaches to glycerol to make glycerol 3-phosphate. In reaction number 6, glycerol 3-phosphate is oxidized to dihydroxyacetone phosphate. And I told you guys before that whenever there's oxidation or reduction reaction, the enzyme is usually dehydrogenase. So in this case, the enzyme is glycerol phosphate dehydrogenase. And to predict whether NAD+ gives NADH or whether NADH gives NAD+, we can see what happens to this molecule. In this case, our molecule is oxidized, so NAD+ would be reduced. So if oxidation happens in our molecule, then this NAD+ or NADH would be reduced, but if this is reduced, then this will be oxidized. And the last stage of this reaction, which is actually a reaction in glycolysis, the dihydroxyacetone phosphate is converted into glyceraldehyde 3-phosphate by triose phosphate isomerase, and these two are isomers of each other, so the enzyme is called isomerase 2, which makes sense. Now let's just review the reactions of how fructose is entered into glycolysis, starting from the glyceraldehyde we made in reaction number 4. So first, the glyceraldehyde is converted into glycerol by enzyme alcohol dehydrogenase, and this is the oxidation reaction. So usually oxidation or reduction reaction is catalyzed by enzyme dehydrogenase, and then glycerol is converted into glycerol 3-phosphate by enzyme glycerol kinase, and glycerol 3-phosphate is oxidized to dihydroxyacetone phosphate by enzyme glycerol phosphate dehydrogenase, and dihydroxyacetone phosphate is converted into glyceraldehyde 3-phosphate by enzyme triose phosphate isomerase. So this concludes my video on how fructose enters glycolysis. Thank you for watching my videos. Hope you guys understood it. If you guys have any questions, please post it below. Thank you. Bye.